LeetCode Problem number 98. Validate binary search tree. So this problem gives us a binary tree, right? And we have to determine whether or not if it's a valid binary search tree, right? So a binary search tree means that the binary tree is sorted in a way, right? So if you see this example, this one, okay, more like you look at this two, all the numbers on the left side are smaller, right? And all the numbers on the right side are bigger than 2, right? So here you have 1, which is smaller than 2. Here you have 3, which is bigger than 2. Okay, for this binary tree, this is not a valid binary tree because you have this 4 here. And like I said, all the numbers below it, all the numbers on the left must be lesser. All the numbers on the right must be more, right? So this 4 and this 3 does not belong to the right side instead, right? So if we were to reorder this, 4 will be here, right? And then let's say this will be 3 turning to 1. Here you can have 5 and then 6, right? In this case, this BST would be valid, right? But in this case, it looks more like a linked list, right? But it's okay, just as long as you understand my point that this is not valid because all the numbers on the right must be more, all the numbers on the left must be lesser. Okay, that is quite important because the way I solve this problem is to use a depth first search, right? So I'm traversing every node and checking whether or not the value is must be more on the value on the left, and the value must be lower than the value on the right, right? Okay, so what I mean by that is, okay, let's say I will use okay I will use this example first. Okay, so DFS root is 2, left is minimum. So let's say I put like this, right? Okay, obviously long min there's more numbers behind this, but for the sake of simplicity, I'll just use -9. But just know that this will be the smallest number possible in a integer, in a long, not an integer. Max will be 99. Okay, so root 2 is 2 more than left. It is, right? And 2 is less than right. Right, okay? So this is valid. So we are going to traverse to the left node first. Later on, we're going to traverse to the right node. And this function, its job is if nothing is wrong, it will return true, right? If it ever not return from here, that means we did not reach the null node. That means something was wrong. This if statement did not trigger, and we have to return false. And when one of it return false, that means this entire binary tree is not a binary search tree. Okay, so that's how this DFS works. So DFS left, I'll open the bracket to indicate this is a recursion. Right, so the root now becomes the left one. My left is still -999, and my max is now the root value, right? Since I'm going to the left side, this number needs to be smaller than this number, right? Makes sense, huh? Okay, so 2. So if we look at it, 1 is bigger than -99, and 1 is smaller than 2, right? So nothing wrong here. We TFS to the left again, but since the left node is a null, so is the right node. So when that happens, this will return true, right? So this will return true. Let's put true here, and then DFS true, right, for the right node as well. for this particular node. Okay, since both of it return true and it's an NN, so this left is true. True. Okay, and then we are traversing to the right again. To the right. So our root will now be 3. Right, going to the right node over here. Our root is now 3. The left is now our root value, right? So this number must be bigger than this number. So our left is now 2, and our right is 99, right? From over here, from our max. Right? I should call this right instead of max. Okay, right. Alright, after that, traverse left again. Right, but it's true because the left node is null, the right node is also null. So both of these will return true. Both of these will return true, indicating this is a up to this point, this subtree, the binary tree so far is a valid binary search tree. So this will return both true. So in this case, our right is returning true. This is also true as well. Okay, when that happens, since both of it is true, using NN, return true over here. So this binary search tree is a valid binary search tree. Okay, so let's see what happens when we encounter a non-valid binary search tree. Okay, so again, our root is now 5. Right, we're starting at 5. We're going to the left node first. Left is negative 99, right is 99. Okay, in this case, nothing is wrong, right? The value 5 will always be in between long min and long max. So we DFS to the left. Right, we're going to the left node 1. Okay, root is now 1. The left is still left, negative 99. The right is now our root value, which is this 5. Okay, so 1 is in between negative 99 and 5, so nothing wrong there. So this will return, so it will recurse again to the left node, but since the left node is null, the left node is null, so this will both return true. Right, so this one will return true, so meaning this left is true. Okay, now we go to the right node. We're going back here, now going to the right node, which is 4. Okay, root is now 4. Our left is root value, which was 5. And our right was the original right over here, 99. Okay, now let's look at this. Now the root value 4 is not more than 5, right? It's not. So when this happens, this will return false, right? So this will return false. We don't need to recurse anymore, so this will return false. And since we are using a NN sign, so both must be true for it to be true. So in this case, this will be false. So we will be returning false for this, meaning that this binary search tree is not a valid, more like this binary tree is not a valid binary search tree. Okay, hopefully I've explained well enough. That's all I have to show. Thanks.